All right, let's talk about the Châtelier principle. We know that most chemical reactions have two processes, and the forward process from the reactant to products, and the backward reactions from the product to reactant. Eventually, the two processes reach the equilibrium. Okay. If the chemical equilibrium is disturbed by changing concentrations of reactants and the products, or reaction temperature and pressure, the equilibrium shifts to a new equilibrium. Okay. This is the Châtelier principle. Let's take a look at the concentration. Okay, you can see this reactants in the chemical reactions, the reactants and the products. Okay, reach equilibrium. This is the symbol of equilibrium. Okay, the forward process and the rate of forward process and the rate of the backward process are the same. Okay, that's called equilibrium. When you add more reactants or reducing products, they move this reaction from the reactant to the products, and they move the equilibrium from the reactant to the products. Okay, then eventually reach a new equilibrium. Reducing reactants or adding products move the equilibrium to the left, okay, from the products to the reactants. Therefore, if we continuously remove the products from the system, eventually we make this reaction reaching completeness. Okay, and all the reactants become products. Okay, this the effects of concentration and temperature. Okay, and we know that the reactions. Okay, reactions we have two types of reactions. One is called endothermic reactions. Another one is called exothermic reaction. Endothermic reactions is the reactions as requires energy. Okay, so for this reaction, for the endothermic reaction, the increase in the temperature move the reaction to the right, move the equilibrium to the right. Okay, when we providing more energies, and the reactions go forward from the left to the right, from the reactant to the product. If the reaction is isothermic, okay, if the reaction release energy, okay, in this case, increasing temperature move the reaction to the left, from the product to the reactant. All right, it's the temperature change. Okay, the equilibrium changes based on the type of the reactions. Okay, if the reaction is endothermic, okay, when we increase the temperature, the reactions changes from the reactant to product. Okay, if the reaction is exothermic, when we increase temperature, the reaction go backward from the product to reactants. Okay, the pressure. The factor pressure only affects reactions involving gas. Okay, because the gas volume changes when pressure changes. Okay, only the gas volume, the liquid and the solid, basically has the pressure has no volume, no effects on the volume of liquid and solid. So the pressure only affects the gases. Okay, increase pressure moves the equilibrium to the low molecular number side. Okay, take a look at the example. Okay, this is the nitrogen react with the hydrogen. Okay, and the one mole nitrogen react with 3 mole hydrogen that form 2 mole ammonia gas. Okay, and you can see on the left side, reactant side, there's 4 moles, 1 nitrogen, 3 hydrogen. On the ammonia side, there's 2 moles. Therefore, when you increase the pressure, the reactions go toward the side with the lower mole numbers. So in this case, they go from the left to the right. Okay, from the reactant to the product, because the products has a lower mole numbers than the reactants. Right, that's the pressure. Let's emphasize that for the biochemistry, because as human body is basically the human body has a constant pressure, so this effect, the pressure has nothing to do with biochemical reactions.